Alright, so this is the final piece to understand how does Pascal's principle, demonstrated in the last video, connect to hydraulics demonstrated in the previous video. So, I want you to look at, first, I'm going to get rid of some of the magic aesthetics and show you, look at this area right here, and look at this area right here. We're going to zoom in, like so, and we're going to place these along the grid lines, and I'm going to use the square function to show you this whole square is equal to 1 meter by 1 meter, like so, right? And this whole stick is equal to 1 meter by 0.1 meter. So that is to just say that the area on this stick is 1/10 the area of this cube. So if we applied it through the the pipe, then this is going to be resulting in, if Pascal's principle stays true, it'll be resulting in 10 times as much force being exerted upwards into the block here. And now I'm going to show you something cool here, right here, not there. The material. This material weighs 1 kilogram. It doesn't matter what the unit is. It's just equal to 1 pound, 1 kilogram, 1 gram, etc. And we're going to be looking at this one. This one is equal to 10 kilograms or 10 pounds or 10 grams. The point is, their relationship is that the green stick is both 1/10 the area of the orange cube and 1/10 the mass of the orange cube. But according to Pascal's principle, when we move this downwards, I have to unlock it first. Okay, when we move this downwards, it's exerting 10 times as much force, again, according to Pascal's principle, since pressure stays multiplying, since there's 10 sticks worth of, volume across, 10 sticks worth of area across this side, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's being exerted upwards in this area right there. When we move this downwards with a force of technically 1 Newton, which will move 1 kilogram, 1 meter per second squared, it's going to result in this force being 10 times as stronger on this side. And since we're moving it 10 times as far, it can go 1/10 the distance right here, 1 meter. 1 meter is 1/10 the distance of 10 meters. So I hope now it's kind of like clicking. Oh yeah, this is both 1/10 as light. I should use percentages. This is 10% as light as the orange cube, the stick, and we're moving it with 10% the strength. But according to Pascal's principle, since this is 1/10 the area of this one, it's going to be resulting in 10 times the strength upwards. We can change it so that this one goes in this side right here, and it moves water, that's filled up, say like, I'm going to be improvising this really quickly. We're going to be making like a different cube, and see there's water there. If we imagine we moved this cube down 10 meters, it could possibly move something that was 10 times as heavy and also 10 times as, ginormous, but that would be a giant cube in comparison. If we could fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, here, let me actually do that again. Here we go. Okay. We can fit 10 cubes across this side, and that's the same way that we can fit 10 cubes or 10 sticks across this side. So if we imagine that we are moving this downwards, boom, into a pipe, and then the pipe, like this whole thing was being, let me select it. This whole thing were being connected to this one, and there was just a bunch of water moving this. We could move something 10 times as heavy if we moved it 10 times as far. So, I sounded a little bit rambling, but I hope that if you were confused on what Pascal's principle was because you're trying to learn about it too, like I was, then this was hopefully helpful, and this hopefully made enough sense and clicked enough pieces for all of us to get it, because I'm really excited about how cool this stuff is and possibly making a physical real life demonstration. But otherwise, these simulations will work for now, and I hope that was helpful, and I hope you enjoyed, even if, even if this just sparks some curiosity in what Pascal's principle is, and you're interested in learning more physics, like I am. So, regardless, I hope you enjoyed, and I hope you have a wonderful day. Bye-bye.